So Andrew, this is the first time that you're seeing your battery installed. Is there anything about this that makes you nervous?
Absolutely, I'm always nervous.
This is Andrew. He's standing next to the first installation of a new kind of battery, one that might just have the power to change the world.
As scientists and engineers, we have a really unique skill set that we can leverage to develop better technologies to actually increase human prosperity.
This is really the missing piece for heavy industry right now to get off of fossil fuels.
The way we power our factories hasn't changed in over 150 years, but these hard-tech entrepreneurs want to bring them into the future.
For the first time in history, renewable energy is actually cheaper than fossil fuels. The problem is it's just not reliable.
The storage has to be there to smooth that out and provide continuous delivery of energy to the customer.
Their battery could finally bridge the gap between renewables and heavy industry, but there's a lot riding on this moment.
Most of the industries that we're serving are running 24/7, 365. The cost of their downtime is really extreme, and so we feel like we're going to get one shot at this.
If it works, these entrepreneurs could transform every industrial factory in the world. But I couldn't believe what was inside their battery.
The key thing that's inside is just solid carbon. So that's a block of graphite.
That's right, it's a rock. So the question is, can a block of carbon really power the battery of the future? Nearly every aspect of our lives benefits from industrial production. Think of the products that we buy, chemicals, agriculture, and the electricity that powers our world. This process requires huge amounts of heat or electricity, and factories want their energy to be as inexpensive as possible, which is why all along the United States you find so many industrial sites close to the sources of fossil fuels.
The industrial sector really caught our eye, and that's because it is the single biggest category of emissions globally. Something like 30% of all emissions come from heavy industry.
The core reason we started Antora was to come up with scalable solutions that could make a difference in the next decade on emissions around the globe.
Over the last few decades, the government has applied sweeping regulations to all kinds of industries to reduce emissions. But since the world's economy runs on factories, these entrepreneurs realize that the best approach is designing a better product.
The cost of energy is super important, so we needed to create a product that was going to be economically competitive in the US and all around the world, and it had to be a no-compromise solution for the customer.
The reason fossil fuels are so hard to beat is that they store a lot of energy and they're dirt cheap. Heavy industry needs energy around the clock, and the only way they can get that right now is by burning fossil fuels, which creates a huge amount of emissions.
With innovations over the last decade, the cost of energy produced by renewable sources is becoming cheaper than fossil fuels. That's great for industrial sites, except for one really big problem.
The biggest challenge has been that those sources of energy are inconsistent, and an industrial facility can't stop producing whatever good or product it's producing when the sun isn't shining or the wind isn't blowing.
The logical question becomes, how do I take these intermittent resources and store them for long enough periods of time to be able to reliably run these operations? The answer is long-duration energy storage.
In other words, we need a battery. But don't we already have those? What makes this one special?
One of the most exciting moments in the process of developing this energy storage solution was when we realized how perfect carbon was as a storage material.
Carbon has all the basics. It's got low cost, existing massive supply chain, and really, really high energy density.
We're able to store a similar amount of energy in a block of carbon that you would in a lithium-ion battery of the same size. But the carbon itself is 100 times cheaper than that same lithium-ion battery.
Okay, but how do these batteries actually work?
Any sort of energy storage has 3 different modes it needs to be able to operate in. So one is charging, one is just storage, and the third is discharging. So for a thermal battery, charging means increasing the temperature. The way we do that in our system is we use electricity to resistively heat carbon, just like a toaster coil, until it's glowing hot.
Meaning really, really hot, like 2,000 degrees Celsius, or about 1/3 the temperature of the surface of the sun. After it's stored, Antora can deliver whatever energy the customer needs, high temperature industrial heat or electricity on demand.
We can take these clean, cheap, but intermittent resources and convert them into something that has the same reliability and the same cost profile as a fossil fuel.
Today, the team is visiting the industrial site where their first battery is being installed. It's a moment they've been working towards for over 5 years.
So these are being installed today, as I understand it?
So they're assembling one of the heaters. It looks like they're working on this one right here.
With Antora's solution, the operating cost of industrial plants like this one will be lower than what it costs them using fossil fuels, while dropping their emissions down to zero. But Antora and their customers have learned that big innovations require working through many different state and federal regulations, which is a challenge in itself.
The future for Wellhead and other energy companies is very promising if you're willing to adapt to the changes. The technology is evolving rapidly here, and sometimes it can be a little frustrating because the regulations need to be updated as the technology evolves.
The industrial energy system in the United States was based around the technologies that were available 50 years ago, 100 years ago. When you start coming at it with a different approach, there are some regulations that just accidentally don't work as well as they used to. So we're really excited to be working with policymakers at the state level, local level, and federal level to help them understand where are things working well and where are things not going to work as well through the next decade of the energy transition.
Private sector innovations like Antora's have the power to make a profound difference on some of the biggest challenges that we face throughout the world. If it works, Antora's battery has the potential to stand on its own as an innovation that's both better for customers and a bridge to providing reliable clean energy for everyone.
We expect to see a lot more boxes like this in the future. My dream is that anytime you're driving by an industrial site in this country or around the world, you're seeing Antora thermal batteries. The US has a huge competitive advantage in that we have incredible solar and wind resources across the country. And I think that's going to drive a re-industrialization of the United States.
The vision we see for the future is really a vision where everybody on Earth has access to abundant energy, where pretty much everything is powered by wind and solar electricity that is run through a thermal battery that can then be used to create on-demand, inexpensive, and zero emissions energy.